The diagram below shows a sketch of the curve with equation y equals bracket x minus 4 bracket x plus 1. Find the area of this shaded region. That's all it says, right? It doesn't say anything about coordinates a or b this time. Okay, it just goes straight into it and says find the area. Okay, we recognize this as a quadratic curve, and to get the area we're going to integrate, and we do need limits. Okay, so there's no harm in calling this a and b, okay, to help us. All right, and of course, just like before, we need to appreciate that a and b are on the x-axis, so we can say, look, at a and b, okay, the curve crosses or cuts the x-axis, therefore y is equal to 0. Now if we look at what they've given to us as y in this case, well, it's quite nice because they've already put it in brackets for us. Okay, so it's already factorized, so you can literally set y to be 0, so you can say therefore x minus 4 x plus 1 equals to 0. So you could say, look, either x minus 4 equals to 0 or x plus 1 is equal to 0. These two times together equals 0. One of them's got to be 0. So x is equal to 4. You take that over, or take that over, x is equal to minus 1. So there you go. There's your a and b. So in what I've labelled a and b, so a will be minus 1, 0. B will be 4, 0. So there are our limits. We know this is minus 1. We know this is 4. Okay, so quite simply then we can integrate a definite integral for our curve between minus 1 and 4. Okay, right, so we need to integrate this now. Okay, and we've got the limits here. And of course, when you integrate this now, you might think, oh gosh, I've got brackets here. How am I meant to integrate brackets? We haven't dealt with this. So when you've got brackets, okay, quite simply, you've got to ask yourself, well, what can I do here to make things easier for myself? Okay, how am I going to be able to integrate this when we've got brackets? Is there a way around it? And of course, there is, isn't there? Because you know when you've got brackets, you can expand them quite simply in this case. Okay, so we could multiply these out. Okay, using FOIL, and we'll get an expression that we can deal with. So when I multiply this out, I got the first there, so I got x squared. I've got outers, which is x times 1, which is plus x. I've got the inners, which is minus 4x. And I've got the lasts then, which minus 4 times 1 is minus 4 with respect to x. So let's just tidy that up a little bit first before I integrate it. So that becomes x squared minus, well, x minus 4x is minus 3x minus 4. So I'm left with having to integrate that, okay? And that's easy enough because x squared becomes x cubed over 3. 3x becomes 3x squared over 2. And 4 becomes 4x, okay, between 4 and minus 1. Okay, so we found a way of writing that as an expression in terms of x squared and x and constants, and we can integrate it as we've done. Now it's a case of putting in the limits. So let's write it over here. Put the upper limit in first, 4 cubed. Okay. So use carefully using brackets there, so we put 4 in there. Take away then, let's put the minus 1 in here. Okay, so then we'll work out the bottom bracket, first bracket. We get minus 56 over 3. And let's work out the second bracket then. Oops. Got to be careful there, but using brackets should help us get this right. So I think I've done that right there. Yeah, so we get minus, then that just comes out to be 13 over 6. So we've got minus 56 over 3, minus 13 over 6. So if I work that out on my calculator, that comes out to be minus 125 over 6. Okay, so again, we're expecting a negative answer out on it because it was underneath the curve and we've got negative y values here. Okay, so expect that, but then you've got to say at the end, therefore area is equal to positive 125 over 6 units squared.